A pleasant day, everyone. I am Adriana Fernandez, and our task for today is about data normalization. We will perform first normal form up to third normal form, so let's begin. For our first problem, given the table here, this is about the details of patient dental appointment. So first, let's answer this. The table shown in figure 1 is susceptible to update anomalies. Provide examples of insertion, deletion, and modification anomalies. So here I provided 3 examples each. First, insertion anomalies. If a new staff is hired, you can add them without creating an appointment. If we want to add a new patient, we must also schedule an appointment. If adding a new appointment, we also need an existing staff and patient for limiting flexibility. So for deletion anomalies, if we delete Jill Bell, and we also lose her appointment records with multiple staff. If we delete Tony Smith, all his associated appointments will be lost. If we delete an appointment, we also lose valuable patient information because it is all because this is all in one group or in one entry. So next we have this modification anomalies. If we change Tony Smith's name, we must update all related records related to Tony Smith's. If we change appointment times, we also need to update multiple entries for each patient. If we modify or change patient's name, we must ensure all records reflect the change that will cause inconsistency. It simply implies that anomalies occur when changes to one data entry requires update or deletion is related. In related records, it can cause risking data loss and inconsistencies. So now let's proceed in performing data normalization. Here, first normal form. For a brief introduction about first normal form. First normal form is about atomic values and unique identifiers. First, a cell must never contain more than one value. So as you can see, I added appointment date and appointment time because from our previous table, appointment date and time was in one column. So I separated them as well as this patient last name and first name. I separated them in one rather than in one patient name, and also this dentist first name and last name. So therefore we conclude that this is first normal form because there is no cell has more than one value. Each row is unique and there are no repeating groups. Next, now we can proceed in our second normal form. Again, for our brief introduction for the second normal form. Second normal form states that it is already in first normal form and it has no partial dependencies on the primary key. In other words, no non-key attribute should depend on or only part of the composite part prime. Here first, we need to identify the primary keys. So the primary keys we have are the staff number, patient number, and the surgery number. Of course, dentist name, dentist first name and last name depend staff number, as well as the patient first name and the patient last name depend on the patient number and the surgery number. So next, for continuation, we have here the appointment ID, where the appointment date, appointment time depend on the appointment ID, and as well as the staff number, patient number, and the surgery number, because these are the foreign keys and they are depend on the appointment ID we created. This appointment ID was not in our given table. We created this for unique identifier. So therefore, we conclude that all data depends on the primary that we created here. Next, we have the third normal form. Third normal form states that it is already in second normal form, we already done that, and has no transitive dependencies. This means that every non-key attribute must depend directly on primary key and not on other non-key attributes. So in this problem, the second normal form and the third normal form remain the same. So I just added their corresponding table name. So the staff table, the patient table, the surgery table, and next is of course, the appointment table. So the primary key was fully defined all non-key columns, and non-key columns do not depend on any other key. Next, we have here the problem 2. An agency called Instant Cover supplies part-time temporary staff to hotels throughout Scotland. The table shown in Figure 2 lists the time spent by agency staff working at 2 hotels. The national insurance number, also known as the NIN, is unique for employee. So this table lists Figure 2 employees of Instant Cover and their contracts to work at hotels. Next. Again, we have here to answer and provide examples of insertion, deletion, and modification anomalies. I also, just like for problem 1, we provided here 3 examples each. So insertion anomalies: if a new hotel opens, we can add it without staff building it records. If we want to add a new employee, we can't do it without a contract. If hiring an existing hotel, we must create contract first. Deletion anomalies: if we delete Diane, we also lose data for hotel information. If we remove hotel H24, all staff records related to it will also be lost. If we delete contract C1024, all associated or all related employee records will also be lost. Modification anomalies: if we change Smith's name, we must update every information related to him. If Sarah White's hours change, we need to update multiple entries. And if Hotel H25's location change, we must update all records related to this hotel. So it also implies that anomalies occur when changes to one data entry requires date or deletion in related records. Now we can proceed in our first normal form. Again, here I separated the first name and last name from the e-name or the employee name. So here, each row is unique, no cell has more than one value, and there are no repeating groups. for our second normal form, we have the primary keys here, the NIN or the National Insurance Number, hotel number. So underneath that, we have the contact number. First, let's have this National Insurance Number, where hours per week, the time spent working by the employee as mentioned in the description above. Because of course it is related to NIN because it is related to our employee here, and it is mentioned earlier that NIN is the unique identifier for the employee. So therefore, these hours per week that's spent by the employee depend on the NIN. Next, we have the hotel number. Hotel location, of course, depend on the hotel number. And we have here the NIN. Then about the employee, of course, it is depend on our contract number as well as the hotel number. This depend on the contract number we have. So it is our primary key, and we have here the foreign key that represent our table. So all data depend on the primary key. And for our third normal form, the tables remain unchanged. We just also added their corresponding table name. So this is our employee table, our hotel table, and our contract table. And we conclude that the primary key was fully defined. All non-key columns and non-key columns do not depend on any other key. So next we have here our problem 3. Given the first normal form, perform the second normal form and third normal form. So the first normal form is given. It's already here. This is our SID, CIDS name, CNAME, grade, faculty, and faculty phone number. Next, for our second normal form, in the given first normal form, as you can see, we have here the FID, but in the given first normal form we don't have that. But let's start here in our SID. So S name, the student name, of course, depend on our student ID. Course name depend on our course ID. Again, we added here faculty ID. So as the primary key or as the unique identifier of the faculty, because it is possible to have a similar name of a faculty member. So we have here the faculty, and of course related to faculty ID, and the faculty phone number related to, of course, our primary key, the faculty ID that we created. So next we have here the 2 foreign keys, and this table manage the relationship between courses and faculty members, showing that faculty members is responsible for each course. So now we have here the non-key attribute, the grade, where this grade depends on the assigned course, and with assigned faculty in that specific course, and that faculty will be the one give the grade to the assigned student. So this row by these columns depends our foreign key that act as the composite primary key, where is the student ID and the course ID. And therefore, we can conclude that all data depend on the primary key. Again, here, we also remain the tables unchanged. And we just name the table as student name, first student table, course table, faculty table, and the course faculty table, and lastly the evaluation table. So the primary key was fully defined all the non-key columns, and the non-key columns do not depend on any other key. Okay. Next, we have the problem number 4. Here we just also need to perform the second normal form and the third normal form. So this is the given terminologies. So note that 754 means 3 products IDs, similarly in 115 means 3 quantities. So this is the given functional dependencies. Here it just state that the table below is now in the first normal form. So we can jump into that. So the first normal form also was already performed, and now we can proceed to our second normal form. Here we identify the primary keys, and we can see that order date and of course the customer ID only depends on the order ID. Next, of course, we have the customer name, and the customer state depends only on our customer ID. Product description and product price depends only on our product ID. And lastly, we have here the foreign keys that act as the composite primary key for our order ID and product ID. So here, for the last table, quantity depends on both order ID and product ID. So therefore, we add these non-key attribute to these two foreign key because it depends on both order ID and the product ID. Again, no changes needed. We just added the name, the table, order table, customer table, product table, and the ordered product table. So where we can see the order ID that already state who's the customer ordered product ordered, and this is where the data was being get. So is added as the foreign key, and those ID. So inside this order ID, we have the customer ID already that is related to the product that he or she ordered and the quantity. So last, we have the problem 5. Given the first normal form, again perform the second normal form and the third normal form. So first normal form, this is our first normal form. So we have here the second normal form. Of course, the department name depends only on our department ID. The employee name depends only in our employee ID, but of course, those employee has corresponding department, so We also added here is a foreign key, the department ID. So of course, it is depend on our primary key, the employee ID. Next, we have this, the properties ID. So properties names, of course, depend on our primary key, property ID. And we have the foreign keys that act as the composite primary key, the department ID, employee ID, and the properties ID, where our business time, of course, depend on those in these three key, in this primary key, in this group. So business time depend on the properties of the employee, where that employee was assigned in a specific in a corresponding department. So again, we just added their table names, department table, employee table, and properties table. Lastly, we have the business table. So that's all for today, and I hope you have learned something new in this video, and thank you for watching.